Hey guys, it's been a long time. I was kind of busy. Uh, from today, sorry about. From today, we will learn about the active and reactive power, kind of deeply. So, the first lecture is about the definition of active power. So let's see. So, as we learn about electricity, many times we saw about this triangle. PQ. P is active power, Q is reactive power, apparent power is S. And actually, we just learn about only, in math, how to calculate it. But it's really important to know about the basic concept, why we needed active power. I mean, why, what's the differences between active power and reactive power? Why do we need to know that, right? So, okay, let's move on. I'll, um, no, first of all, you know, um, active power, this P side, we generally say P is, actual usage. You know what I mean? For example, this picture, motor, or, heater, using resistor, right? So, which means we actually use it, you know, it's working and that it's gone. But instead, the reactive power is, like for example, I gave you money and you spend it. That means, it actually you use and it's gone. It's an active power. But instead, the reactive power, I gave you money, but you save it and you didn't, use it and you return it back. That is a reactive power. So we need to learn about a little bit about power system. So look at that. In in general, power system, like in the daytime, our mainly load is motor, right? Motor. So motor, our generating system, look at that. Here V, and here's a load. I mean, is a motor, right? So I will change it a little bit more. This is generator, and then go to the here. Motors, we need to indicate it in R here, L. This is our, general uh, power system in daytime. You know what I mean? So it's a motor is our, mainly consumers. You know what I mean? In power system, like refrigerator or in the factory, they need to use it, right? Actual use. So what I wanna say is, I said our active power is actual usage, right? So we need to indicate it this as it R. R is, as we know, register, right? But this is actual usage, you know what I mean? But instead L, this is core. Motor is made it core, right? So we say the motor actually consume P active power and Q. Actually, it needed both of them needed, but we need to explain it in the circuit. P is we indicated R, and Q is L or C. You know what I mean? Depending on the load. So yeah, we actually didn't know that about the motors. Only need active power or reactive power. We didn't expect to use it need possible active and reactive power, but actually it needed. So later we will learn about the motors and transformers, and generator. Why, uh, P is related frequency and Q is related excitation current. You know what I mean? Like you don't need to know about it now, but we will later learn about it. You know. So actually, motors, consume P and Q. Now, just to try to understand why we indicated this P and Q in the circuit. You know what I mean? So P is indicated our actual usage, and Q is L. This meaning. So yeah, and so that's why I said this is a source, right? Voltage source. So generator. So it actually needing generate like a P and Q. But later we will learn also about it. But making both of them P and Q, and then this is from generator. You know what I mean? To sending the current to our house is kind of a far away, right? So there's you know kind of huge amount of loss. You know what I mean? Power loss. So that's why we need to also step up and down transformer, and and later we will also learn about generator. This is not efficient to also make a Q. It also make it a little bit, but what I mean is it focusing on making P. You know what I mean? Active power. So that's why we make it like in the substation like a capacitor bank, or to provide like as a supplier. You know what I mean? Like a reactive part. So now just today I don't want to talk too much about the Q part. You know what I mean? Just try to understand the P's concept, right? So you look at that. So if I say like a P is we could explain in because of the same amount of usage. So we say as it R, right? So as we know, in the R load, VI is phase is in phase, right? It's the same. So what I mean is where is it? Sorry guys. Oh yeah. So what I wanna say is in R, pure R circuit, we say VI is in same phase, in phase, which means there's between them there's no difference angle. You know what I mean? The only difference is the dimension. So we could draw if it's I and V is like that, right? So V is this color. So we could explain this, and then later I will show you about you guys a little bit about the math part. So we could explain in this pager, time pager to the just time domain to the pager. So first of all, we explain this first of all by t root 2 by sine omega t and I t root 2 sine omega t minus theta. But in this time, this is in page I said. So we don't need to actually this theta right now. So which means if we indicated drawing in pager. So this V is now RMS, not peak. And the I is also 0. So so P is VI cosine theta, right? But since they are in page, this is 1. So P is VI. So if we, VI, if we multiply. So actually it indicated VI here, first part here, right? VI plus plus is plus, right? And minus minus is here also plus, and plus plus is here. So we could explain this like that, like so if we and from this value, if we divide it like a average value, so this is we say average power here, this part. Sorry about color. I guess, yeah, this color here. So we say this is P is VI. So actually P is average power. Yeah, that's it. I wanted to explain today. See here, guys. So what I wanted to say is VI is in phase. So between them, there's no angle differences. Only differences is dimension, right? So that's why if we see this VI multiply here, if we multiply here, and then if we try to find out the average value is actual power usage. Yeah, that's it, today's lecture. Next.